70 tons of reinforced steel shudders to life beneath a sky permanently stained with sawdust haze. Gears grind into motion with a sound closer to thunder than machinery. Deep, violent, absolute. The ground itself trembles as the cutting arm lowers, its serrated teeth accelerating into a blur, spinning faster than the eye can resolve. In less than 3 seconds, a tree older than any man present, 2 meters thick, rooted for over a century, is severed clean through. It does not fall with dignity. It collapses like a condemned structure, shearing through branches, splintering neighboring trunks, crushing the undergrowth into pulp. The impact sends a shock through the soil, through the boots of the men standing too close. Then the machine turns. There is no pause between destruction and demand. The next trunk is already marked in chalk, already claimed. Workers move quickly, too quickly, boots slipping in mud slick with sap, oil, and something darker. Signals are shouted, but the engine devours sound. Instructions dissolve into noise. A moment of miscalculation here is not an error, it is an erasure. The rotating blade does not distinguish between hardwood and bone. It consumes both with identical indifference, leaving nothing but fragments. In the distance, another tree drops, then another, then 5 more in rapid succession. The forest does not thin, it retreats. Entire sections vanish within hours, stripped to raw earth and shattered stumps. What once stood dense and layered becomes an exposed skeletal plain. The air thickens with dust. The noise never stops. And still, the blade does not hesitate, because hesitation would mean control, and this machine was built without it. It begins with a promise, not of destruction, but of mastery, not of loss, but of expansion. The machine is introduced as a solution, an answer to scarcity, to distance, to the slow inefficiencies of human labor. Timber is no longer merely a resource. It becomes a currency of scale. Railroads demand it. Cities consume it. Mines depend on it. Entire economies begin to hinge on the speed at which forests can be converted into usable form. And in this equation, the 70-ton steel reaper emerges not as an anomaly, but as inevitability. It is called progress. Measured in output, it is undeniable. What once required teams of men laboring for days can now be completed in minutes. A single machine replaces dozens, then hundreds. Production curves rise sharply, costs fall. Supply chains expand into territories previously considered inaccessible. Forests that stood untouched for centuries are suddenly within reach, mapped, marked, and scheduled for removal with mechanical precision. But progress in this form carries a contradiction embedded deep within its design. The same force that multiplies productivity also amplifies consequence. Every gain in speed reduces the margin for human response. Every increase in scale distances decision-makers from the physical reality of the work. The machine does not tire, it does not hesitate, it does not question. And so the system built around it begins to mirror those same qualities, relentless, unyielding, indifferent. Efficiency becomes its own justification. Within this framework, safety is redefined not as a necessity, but as a variable cost. Time lost to caution is calculated against output gained through risk. Workers are trained not to control the machine, but to keep pace with it. The rhythm of labor shifts from human endurance to mechanical demand. To fall behind is to become irrelevant. To misstep is to become expendable. And the forests, vast, ancient, seemingly inexhaustible, begin to reveal their limits. What was once perceived as abundance is exposed as finite under the pressure of industrial extraction. Entire ecosystems collapse not over generations, but within a single operational cycle. Soil erodes. Water systems destabilize. Wildlife disappears without record. Yet the machine continues, because its purpose is not to sustain, but to convert. This is the paradox. A system designed to extend human capability begins to erode the very conditions that make that capability meaningful. The machine increases reach, but reduces restraint. It generates wealth, but concentrates risk. It promises control, yet operates beyond it. And at its center stands the blade, turning without judgment, without memory, enforcing a logic that cannot slow itself down. Before the blade, there was rhythm, not silence, but a measured continuity, cycles that operated without urgency, without acceleration. Forests expanded and contracted according to forces that did not seek efficiency. Growth followed seasons, not schedules. Trees rose over decades, sometimes centuries, their density shaped by soil, water, and the slow negotiation between species competing for light. Nothing in this system moved quickly, yet nothing was wasted. Human presence existed within this balance, but it did not dominate it. Early logging was deliberate, constrained by limitation. Axes cut only as fast as muscle allowed. Two men with a crosscut saw could bring down a single large tree in hours, sometimes longer, their progress dictated by fatigue, by weather, by the grain of the wood itself. Each cut required planning. Each fall demanded space, coordination, and attention. Mistakes carried consequence, but they unfolded within a scale that remained visible, comprehensible. Extraction in this form was selective. Forests were not cleared, they were entered. Specific trees were chosen, those straight enough for beams, large enough for shipmasts, durable enough for long-term use. The rest remained. The canopy held. Root systems continued to stabilize the ground. Wildlife adapted, displaced but not eradicated. Even as timber fed early industries, the pace of removal allowed regeneration to occur in parallel. Time, not machinery, governed the exchange. Communities formed around this limitation. Logging camps were small, often seasonal. Workforces numbered in dozens, not hundreds. Knowledge passed through experience rather than instruction manuals. Men understood the weight of the trees they cut because they felt it directly. The resistance of fibers, the unpredictability of a falling trunk, the force required to move what had been felled. There was risk, but it was intimate, immediate, tied to physical awareness rather than mechanical abstraction. Transportation reinforced these boundaries. Rivers carried logs downstream, but only during specific conditions. Spring melts, controlled flows. Overland movement relied on animal power or rudimentary sled systems. Distances imposed natural constraints. Remote forests remained untouched, not by choice, but by inaccessibility. What could not be reached could not be taken. Within this system, the forest retained its continuity. Clearings existed, but they were temporary interruptions rather than permanent erasures. Regrowth followed disturbance. Soil remained anchored. Water cycles persisted without disruption. The land absorbed human activity without collapsing under it because the scale of that activity never exceeded the system's capacity to recover. But this balance was not preserved by intention. It was enforced by limitation. The absence of steel, of engines, of concentrated mechanical force meant that human ambition could not fully translate into action. Demand existed, expansion was desired, but without a mechanism to accelerate extraction, the forest remained partially protected by the very inefficiencies that defined early industry. That protection would not last, because once limitation is removed, restraint must be chosen, and the arrival of the machine would prove that it would not be. The transition does not arrive quietly. It begins with pressure, economic, geographic, and mechanical. By the late 19th century, the demand for timber outpaces every traditional method of extraction. Rail networks expand across continents, requiring vast quantities of wooden ties. Urban centers rise vertically, consuming beams, scaffolding, and fuel at an unprecedented rate. Shipbuilding intensifies. Mining operations push deeper, reinforcing tunnels with timber that must be replaced constantly as it decays under strain. What was once a resource becomes a dependency, and dependency demands acceleration. Steam is the first force to fracture the old limits. Portable steam engines enter the forests, dragging with them cables, winches, and the ability to move logs that no team of animals could shift. The introduction of the steam donkey, a machine capable of hauling multiple felled trees simultaneously, reshapes the geometry of logging sites. Terrain that once resisted extraction becomes accessible. Slopes are no longer barriers. Distance begins to collapse. But movement alone is not enough. The bottleneck shifts from transport to cutting. Axes and crosscut saws, bound by human endurance, cannot keep pace with the expanding infrastructure that feeds on timber. The gap between demand and capability widens. Into that gap, engineers begin to design something larger, heavier, and fundamentally different. A machine not intended to assist the worker, but to replace the limitations that define him. Steel becomes the medium of that transformation. Early mechanized saw systems emerge as experimental constructs, fixed installations powered by steam belts, capable of processing logs once they are delivered. But the forest itself remains resistant. Cutting still happens at the source, where mobility is constrained and conditions are unpredictable. The solution is not refinement, it is escalation. The saw must move into the forest. By the early 20th century, the first mobile heavy saw platforms appear. Massive, reinforced frames mounted on tracks or crude-wheeled bases, powered by internal combustion engines that eliminate the dependency on stationary steam sources. These machines are not precise, they are not efficient in any modern sense, but they are powerful beyond comparison. A single rotating blade, often exceeding 2 meters in diameter, can sever a trunk in seconds where men once labored for hours. From this lineage, the 70-ton steel reaper takes form. It is not a single invention, but an accumulation of stronger alloys, more compact engines, improved torque transmission systems. Weight increases not as a flaw, but as a requirement. Stability under cutting force demands mass. Resistance against recoil requires structural density. Every component is overbuilt, reinforced, designed to endure stress levels that would shatter lighter machines. By mid-century, the fully realized system stands as a convergence of industrial priorities. 70 tons of steel, gear assemblies, hydraulic arms, and rotating blade systems integrated into a mobile platform capable of entering dense forest and converting it into cleared land at a rate previously considered impossible. It does not rely on teams. It requires only operators and support workers, fewer men, but each positioned closer to a force they do not fully control. Production metrics redefine success. Output is measured in volume per hour, in hectares cleared per day, in cost per cubic meter reduced. The machine delivers on all fronts. Logging operations expand deeper, faster, more aggressively. Forests that once resisted extraction due to terrain or density are now targeted precisely because they contain the highest yields. The reaper is not hidden, it is celebrated. Industrial journals describe it as a breakthrough. Investors fund its proliferation. Governments seeking growth incentivize its deployment. The language surrounding it is one of advancement, of inevitability, of human capability finally unbound from natural limitation. But within its structure, something has already shifted. The machine does not scale human effort. It replaces it with something that cannot slow down. And once deployed, it will not remain contained. The machine is not a single mechanism. It is a convergence of systems, each engineered to withstand forces that operate at the threshold of structural failure. At 70 tons, its mass is not incidental, it is essential. Every kilogram exists to counteract motion, to absorb vibration, to prevent the entire structure from tearing itself apart under the stress of its own operation. At its core is the cutting assembly, a circular blade often exceeding 2.5 meters in diameter, forged from high-carbon alloy steel, reinforced along its rim with hardened teeth designed to maintain sharpness under continuous impact. Each tooth is angled with deliberate asymmetry, optimized to slice through dense fibers while ejecting debris outward at high velocity. When engaged, the blade rotates at several hundred revolutions per minute, generating a peripheral speed that transforms it from a tool into a force field, an invisible boundary of destruction extending meters beyond its physical edge. Power is delivered through a multi-stage transmission system. An internal combustion engine, often exceeding 1,000 horsepower, feeds torque into a series of reduction gears designed to convert raw rotational energy into controlled, sustained force. These gears are not delicate components. They are massive, interlocking structures, lubricated under pressure, encased in reinforced housings to contain the shock loads that ripple through the system each time the blade meets resistance. Hydraulics provide movement. The cutting arm, an articulated structure capable of extending, lowering, and angling the blade, is driven by hydraulic cylinders operating under pressures that can exceed 3,000 psi. These cylinders translate fluid force into mechanical motion with minimal delay, allowing operators to position the blade with a degree of precision that belies machine size. Yet this precision is conditional. Under load, the system flexes. Metal bends with intolerances. Response times shift by fractions of a second, small deviations that carry enormous consequence when the blade is engaged. Stability is enforced through the chassis. A reinforced steel frame distributes weight across tracked or multi-axle systems designed to maintain traction on uneven, often unstable ground. The machine does not glide. It advances with resistance, compressing soil, crushing undergrowth, leaving behind compacted paths that alter the terrain permanently. Suspension systems, where present, are minimal. Comfort is irrelevant. Structural integrity is not. The operator is positioned within this structure, but not outside its influence. Encased in a cabin reinforced with steel plating and, in later models, laminated safety glass, the operator interfaces with the machine through a network of levers, pedals, and pressure-sensitive controls. Visibility is limited. Dust, debris, and vibration obscure clarity. The machine communicates not through feedback systems, but through resistance, through the feel of strain in the controls, the pitch of the engine, the subtle shifts that indicate imbalance or overload. There are safeguards: emergency shutoff mechanisms, pressure relief valves, protective guards around exposed components. But these systems are reactive, not preventative. They engage after thresholds are crossed, after conditions become unstable. They are designed to limit damage, not eliminate risk, because elimination would require slowing the machine.
And slowing the machine would undermine its purpose. Every component, every system, every reinforced joint is aligned toward a single objective: uninterrupted operation under maximum load. The design does not prioritize adaptability, it prioritizes endurance at scale. And within that design lies a critical truth. The machine does not fail gradually. When its limits are reached, it fails all at once. The machine is calibrated for output. Every parameter, rotation speed, torque delivery, hydraulic response, is optimized not for caution, but for continuity. The objective is not merely to cut, but to cut without interruption. In this framework, safety is not engineered as a primary system. It is layered afterward, constrained by the limits that productivity will tolerate. The blade's velocity is the first compromise. At lower speeds, control improves. Resistance can be felt, adjustments made before instability escalates. But lower speeds reduce output, and reduced output disrupts the economic model that justifies the machine's existence. So the blade is driven faster, hundreds of revolutions per minute, each tooth striking wood with explosive force. At this velocity, cutting becomes less a process and more an event. There is no gradual penetration, there is only impact, repetition, and removal. Human reaction cannot match it. From the moment the blade contacts a surface, the window for intervention collapses to fractions of a second. A misaligned cut, a shifting trunk, a hidden internal fracture in the wood, any of these can redirect force unpredictably. The machine continues regardless. It does not pause to assess. It does not recalibrate in real time. It executes. The margin for error is reduced to near zero. Hydraulic systems introduce a second layer of risk. Operating under extreme pressure, they enable rapid positioning of the cutting arm, but they also store energy in a form that is both invisible and volatile.
A compromised seal, a weakened hose, a microscopic fracture in a fitting. These are not gradual failures. When they rupture, they release force instantaneously. Components snap back. Fluid escapes at velocities capable of penetrating skin. The arm, momentarily unrestrained, can shift beyond intended limits before control is reestablished. Yet maintenance schedules are compressed. Downtime is measured against cost. Each hour the machine is inactive represents lost production, delayed contracts, financial penalties. Inspections are performed, but often within constrained windows, under pressure to return the system to operation. Components that should be replaced are reinforced. Warnings are noted, deferred, absorbed into the ongoing calculation of acceptable risk. The operator is positioned within this equation, trained to interpret the machine's behavior, expected to anticipate failure modes, required to respond within timeframes that approach the limits of human perception. Fatigue accumulates, hours extend. Environmental conditions, heat, noise, vibration, erode concentration. Yet the pace does not adjust. The machine dictates rhythm. The operator adapts or is replaced. Communication systems degrade under load. Engines at full output generate continuous noise levels exceeding safe thresholds. Verbal signals become ineffective. Visual cues are obscured by dust, debris, and motion. Coordination between workers relies on assumption,
on routine, on the expectation that each individual will act predictably within a system that is inherently unpredictable. Redundancy is minimal. Backup systems exist, but they mirror the same priorities as the primary ones: speed, efficiency, continuity. There is no secondary mode designed for safe operation at reduced capacity. There is only full operation or none at all. This is not oversight, it is design logic. Risk is not an unintended byproduct of the machine. It is embedded within it, a necessary condition for achieving the scale of output required. To reduce risk would require reducing speed. To reduce speed would require redefining success. And within the industrial framework that produced the steel reaper, such redefinition is not considered viable. So the machine operates at the edge of control, and the edge does not remain stable. The day begins before light. Engines are checked in darkness, their metal surface is cold, damp with condensation that settles overnight across the clearing. The air carries a layered scent: fuel, oil, wet soil, and the faint organic decay of disturbed forest floor. Workers arrive in silence or in fragments of conversation that dissolve as the machine is prepared. There is no formal signal to begin. The ignition itself becomes the declaration. Once the engine turns, the environment changes. Sound replaces space. The low, sustained roar of combustion fills the clearing, building into a constant pressure that compresses thought, distorts communication, and isolates each worker within a narrow field of awareness. Hearing protection, where provided, dulls the edge but not the force. Vibration travels through the ground, through boots, into bone. The body adjusts not by resisting, but by absorbing. Roles are defined by proximity. The operator occupies the cabin, elevated but enclosed, managing the cutting arm through a sequence of movements that must become instinctive. Outside, ground workers move within the machine's radius, marking trees, clearing debris, guiding the fall of trunks that no longer behave predictably under mechanical force. Each position carries its own exposure, its own set of risks, but all are bound to the same condition: continuous motion. There are no true pauses. When the blade stops, it is not rest, it is transition. Fueling, repositioning, recalibration. The expectation is that the machine will resume as quickly as possible. Workers eat in intervals measured against operational gaps. Breaks are compressed, often taken within sight of the machine, as if distance itself would disrupt the rhythm that must be maintained. Fatigue is cumulative and structural. 12-hour shifts extend into 14, then 16, depending on demand, weather windows, contractual deadlines. Sleep becomes fragmented, insufficient. Reaction times lengthen, judgment narrows. Yet the machine does not adjust. It continues at the same speed, the same intensity, requiring the human system around it to compensate for its own decline. Injury is not exceptional, it is integrated into the experience of the work. Minor cuts, bruises, strains, these are expected, unrecorded, absorbed into routine. More severe incidents, crushed limbs, lacerations, fractures, occur with enough frequency to alter behavior without halting operation. Workers learn to anticipate danger not through formal instruction, but through observation of consequence. They remember where others stood when the blade shifted unexpectedly, where a cable snapped, where a trunk fell against projection. There is a language built around these events, not formalized, not documented, but shared in fragments. Warnings embedded in casual remarks, in gestures, in the way a worker hesitates before entering a certain zone. This knowledge is precise but incomplete. It evolves continuously, shaped by new incidents, new near misses, new adaptations to a system that remains fundamentally unstable. Isolation intensifies the condition. Logging sites are often remote, positioned far from medical facilities, far from oversight structures that might impose external limits. Response times to serious injury extend beyond what would be considered acceptable in controlled environments. Decisions are made locally, under pressure, with limited resources. The machine does not wait for resolution. It continues unless physically incapable of doing so.
The psychological weight accumulates. Workers operate within constant proximity to potential harm, aware of the machine's capacity, aware of their own limitations within its reach. This awareness does not manifest as continuous fear. It becomes normalized, integrated into routine, suppressed to maintain function. But it does not disappear. It surfaces in moments, Brief hesitations, altered movements, the instinct to step back half a second earlier than necessary. And sometimes that half second is the only margin that exists. Because within this system, human presence is not central, it is conditional. The machine defines the environment. The workers exist within it, adapting, enduring, recalibrating themselves to match a force that does not recognize them. The first incident is recorded as an anomaly, a miscalculation, a deviation from procedure, a single moment in which the system fails not because of design, but because of human error. The report is brief, structured, and conclusive. A worker positioned too close to the cutting radius is struck by debris ejected from the blade, fragments of hardwood propelled with sufficient force to penetrate protective gear. The injury is severe but contained. Operations resume within hours. The machine is not questioned. Instead, the narrative forms around correction. Training protocols are adjusted. Distance markers are repainted. Instructions are repeated with greater emphasis. The assumption is that the system remains sound, that the failure exists at the level of execution rather than structure. It is an interpretation that preserves continuity, that allows production to proceed without interruption. But the incidents do not stop. They begin to accumulate, not as a pattern immediately visible, but as a series of isolated events dispersed across sites, across crews, across time. A hydraulic line ruptures without warning, releasing pressurized fluid that slices through exposed skin. A cable under tension snaps, recoiling with enough force to fracture bone. A tree, partially cut, shifts unpredictably, collapsing in a direction not accounted for by standard procedure, crushing a worker who had positioned himself according to training. Each event is documented. Each is categorized, analyzed, and resolved within its own frame. Reports identify contributing factors: fatigue, miscommunication, equipment wear. Recommendations follow: increased vigilance, improved maintenance, stricter adherence to protocol. The language remains consistent. The machine is not the source, it is the context. Near misses outnumber recorded injuries, moments in which the system approaches failure but does not complete it. A blade catches an internal knot and deflects slightly, altering its trajectory by degrees that would have been catastrophic had a worker been positioned differently. A support structure holds under stress that exceeds its rated capacity, preventing collapse by margins too narrow to measure without instrumentation. These events are observed, remembered, shared informally, but they do not enter official records with the same weight as measurable harm, because absence of injury is interpreted as absence of failure. This distinction becomes critical. It allows the system to continue operating under conditions that have already demonstrated instability. It reinforces the belief that risk can be managed through behavior rather than addressed through redesign. It shifts responsibility downward, onto those with the least control over the variables that define the environment. Supervisory structures begin to adapt, not by reducing exposure, but by normalizing it. Safety briefings expand in duration, but not in scope. Emphasis is placed on personal accountability, on situational awareness, on the ability of individual workers to anticipate and avoid hazards that are, by design, unpredictable.
The burden of control is redistributed without altering the system that generates the need for control. The first fatality alters the tone, but not the trajectory. It occurs during a routine operation. No deviation from established procedure. No identifiable error that can be isolated and corrected. A sequence of standard actions unfolds, and within it, a variable shifts, small, unrecorded, but sufficient. The blade engages, the trunk responds, and the outcome diverges from expectation by a margin that cannot be reversed once initiated. The report is longer, more detailed, more cautious in its language. It acknowledges complexity, references multiple contributing factors, suggests areas for further study. But it does not conclude with structural indictment. It does not halt operations. It does not redefine the system. It absorbs the event and continues, because to stop would require a recognition that the machine, as designed, produces outcomes that cannot be fully controlled. And that recognition would demand change at a scale the system is not prepared to accept. It begins with a sound that no one recognizes until it is too late. A shudder travels through 70 tons of steel, a resonance that shakes the ground beneath boots, rattles the cabin, and vibrates through bone. The engine continues, oblivious, pumping torque into gears that have exceeded their tolerance. Hydraulic arms oscillate unpredictably, the blade tilting by degrees that should be impossible. Workers instinctively step back, but space is limited and speed is relentless. The margin between safety and catastrophe collapses to a single heartbeat. A trunk splits unevenly. Internal stresses redirect the fall. A secondary tree, destabilized by previous clearing, topples into the path of the machine. The cutting arm strikes, recoiling violently. Chains snap. Hydraulic fluid sprays like molten metal. Dust and splintered timber fill the air, reducing visibility to near zero. Within seconds, a worker is struck, pinned beneath the shifting weight of debris. The operator struggles to halt the system, but momentum resists intervention. There is no gradual failure. There is only escalation. The machine itself begins to consume space, to extend beyond its intended perimeter. Every movement generates secondary hazards. Felling a single tree initiates a cascade. Branches fracture, adjacent trunks tilt, soil shifts under compressed tracks. The clearing becomes a battlefield of unpredictable vectors, metal and wood colliding with lethal indifference. Shouts are lost in the roar. Hands reach for controls, only to encounter resistance from systems that refuse to yield. Emergency mechanisms engage, but imperfectly. Pressure relief valves hiss, slowing some movement but redirecting forces elsewhere. Guards hold in place, yet debris bypasses them through angles unanticipated by design. The operator, aware of human lives within this kinetic web, is paralyzed between instinct and calculation. Every command produces both mitigation and new hazard. Every action ripples unpredictably. By the time the machine stops, whether due to structural failure or exhausted operators, the clearing is transformed. Trees lie across one another in chaotic splinters. Soil is churned. Workers lie injured, their positions marked by debris trajectories and the relentless logic of metal. The first fatalities are counted, but there are others, unrecorded, obscured by dust and commotion. In the aftermath, silence falls, but only superficially. The air trembles with the memory of force. The forest itself seems to recoil. The steel reaper sits still, inert yet charged with the potential of repetition. It has proven its power, and the consequences are only now beginning to be measured. The lesson is unmistakable. The machine does not negotiate. It enforces, and it does not forget. Reports are filed. The language is measured, technical, careful. Words like incident, unfortunate, and operational anomaly dominate the official narrative. Names are recorded, injuries are catalogued, costs are calculated. The machine is described in terms of output lost, replacement parts required, and minor procedural adjustments. Human suffering is quantified only insofar as it intersects with productivity. Responsibility is diffused. The blade remains, silent yet unaccounted for in moral terms. Management convenes. Meetings focus on schedule disruption, insurance implications, and reputational risk. Structural flaws are minimized. Engineering assessments acknowledge stress tolerances, but frame failures as exceptional or externally induced. Recommendations center on training, increased supervision, and stricter adherence to existing protocols. There is no discussion of design philosophy, no interrogation of the machine's inherent volatility. Its destructive potential is treated as peripheral, a byproduct rather than central. Operational continuity is prioritized. Shifts resume within days, sometimes hours. Replacement workers are deployed. Injured employees are rotated out or returned after minimal recovery. Downtime is calculated with precision. The reaper does not pause. The forest has been mapped, contracted, and scheduled. Interrupting its function threatens not only immediate profit, but the entire industrial model that justifies its existence. Regulatory oversight is limited and fragmented. Inspections are conducted, but rarely with the intensity required to evaluate systemic hazards. Safety standards exist, but enforcement is uneven, inconsistently applied across regions and jurisdictions. Reports are submitted, but follow-up is delayed or deferred. There is a structural failure in governance as well as in machinery. Oversight systems are incapable of comprehensively assessing the operational realities of a 70-ton instrument of destruction. Workers absorb the consequences. The labor force internalizes risk, adapting behavior to survive within a framework that does not protect them. Fatigue, stress, and injury compound. Morale diminishes, yet the output continues.
The machine enforces compliance through its operational pace. It is indifferent to protest, to hesitation, to human limits. Survival becomes a function of alignment with mechanical tempo, rather than adherence to ethical or procedural standards. Corporate narratives shape perception. Public communication emphasizes innovation, efficiency, and economic necessity. Accidents are framed as rare exceptions, mitigated through procedural refinement rather than technological redesign. The broader systemic risk, forests cleared beyond sustainable rates, workers exposed to extreme hazard, equipment operating at the threshold of catastrophic failure, is obscured by metrics that favor production over prudence. The pattern is reinforced. Every minor failure normalized, every warning absorbed into routine, every human cost discounted, allows the system to continue. The machine, structurally capable of repeating catastrophe, remains central to industrial ambition. It functions as designed, relentlessly, efficiently, without moral consideration. The forests and its laborers are reshaped, and the consequences ripple outward, unseen by those whose calculations measure only volume and cost. The forests, once vast, dense, and layered, are now fragmented expanses of stumps, mud, and shadow. Soil has been compacted, streams rerouted, ecosystems destabilized. The relentless rhythm of extraction has replaced centuries of natural accumulation with absence. Species that once thrived in old-growth shade have vanished or retreated. The canopy, broken and skeletal, offers no protection, no cover, no continuity. Where a forest should breathe, it suffocates under the memory of steel and motion. The human toll is etched in records, but more vividly, in memory.
Communities remember names, incidents, moments when lives were claimed by a machine whose logic was mechanical rather than moral. Families recount experiences that defy formal documentation, the sudden shifts, the missed signals, the blade that spun with terrifying indifference. Workers carry scars, both visible and invisible. Their bodies are altered, their perceptions are shaped by the relentless force that once defined their labor. Regulation eventually arrives, decades behind the curve. Safety protocols evolve, inspections tighten, limits are codified. But these measures cannot restore what was lost. They cannot resurrect forests cleared in a matter of months, or recover the rhythm of human work once dictated by muscle, judgment, and lived experience. Nor can they fully account for the choices deferred, the warnings ignored, the design compromises that elevated productivity above life. In industrial history, the steel reaper becomes a symbol, not only of technological prowess, but of hubris, of the moral compromise inherent in machines that extend human capability without proportionally extending human judgment. It is cited in engineering texts, in labor studies, in environmental analyses. It is remembered as both marvel and menace, a testament to scale, efficiency, and the human cost embedded in calculation. And yet, amid the devastation, fragments of continuity persist. Regeneration begins slowly where stumps remain, where soil retains some integrity. Survivors carry knowledge forward, reshaping labor practices, influencing engineering, enforcing limits that were once invisible. Memory becomes the repository of warning, and the forest, though diminished, teaches the consequences of a machine that does not hesitate. The blade remains, in history if not in presence, an enduring symbol of power without pause, of progress divorced from restraint, of a system that consumes both land and life in equal measure. The forests bear witness.
The bodies bear witness, and those who remain are tasked with remembering, regulating, and ultimately reconciling the scale of ambition with the fragility of what it touches.